How's it going, everyone? Welcome. Elier Gonzalez. That's right. Now, in this video, we're going to explore the global scope and something beyond, or to understand now the not so secret life of variables in JavaScript, aka to understand now how those variables behave in different scope and why we even care about looking at the scope, because a scope and variables, working with variables and in a scope, is now the way how in our programs we can organize functionality and wrap them so we can then, when we need it, run it or deliver it, right? So I think that this story, in order to describe how the things happens, first is the way how the mind works. So no matter, or I will argue that, right? I have a couple of friends, journalists friends, right, where they have some motto in the how do you call it, on the faculty, right? Which say, hey, trust no one, okay? Or learn to doubt. More like trust no one is like learn to doubt of everything. That's fine, that's great. It's also quite helpful and useful. But again, like in any tool, uh, you must yield that with careful, because you don't want to get chop off your fingers. So, in any case, I mention only that is because I am linking is this concept of the way how the mind is captured, is seduced in terms of how do we understand things. Why is we ask when we had 4 years old, most of us started to ask questions that nobody uh, perhaps has asked before, or not even your parent can tell you that, because that's not the things that we have passed through. All right. Or perhaps your parent, they don't never ask those kind of questions. So in any case, but the thing here is, on today's video, is to now understand that, right? And I do think also that is important and relevant to understand that now how JavaScript fits in the world. So not only know is the internal aspects of the language, of what is a program, how you can work with variables, and what is the different way of how you can define values and the different type of values. What are a values? How can we describe values? How we can hold values inside of variables or as a containers, and why, for example, we care so much about functions and scope, because this is something that we can use inside of the language as a value. So in any case, you can describe now a set of statements and then hold them to be later on executed when you need it, whether programmatically or by responding to some third-party events. Okay, and I think this is quite powerful. And also is to understand that how you can now work with values, how you can convert one value to another, how you can now compare those values, what the comparison mean from JavaScript, and what a function looks like in the JavaScript. What is the role of function in JavaScript? Whether it's a procedure or a mathematical strict definition of a function, right? And how now functions allow us is to organize our code in ways that uh, can be is later on be executed or delivered, right? So whether it's function or class, which is another way of how we can encapsulate now data and its functionality, as well as modules, all right? And this is just to understand is this huge broad stroke of variables, or at least the JavaScript programs, and also is the the social aspect of the language, which is who made this, who owns the legal trademark, who oversees the spec, and which is this TC39 group, and what this group is all about, what they're doing, what is the job, and how their how they make their work, right? How it works, and also is that, well, how now is the language in itself works, all right? If this is a compiler, this is an interpreted language, and what are the new features that, not that new, but what are the features that allow us to optimize or write code that have a good chance for optimizing and running our code. So, for example, with strict mode, all right, and also to understand is the concern about the speed, or yeah, the speed of this language, whether it is like any scripting language. There's a concern that, hey, because you're reading or conceptually this scripting language is say, hey, I'm gonna execute that one after another, right? Like an actor memorizing his line and then telling that on the TV or on the camera, all right, or any influencer as well, all right. So it's pretty much that, okay. So there is a concern of how fast you can actually do that, unlike when you now know everything beforehand, right? So this is, and I really love about this book because it's now creating is this, as I mentioned before, this narrative around the truth of JavaScript, especially now as the more competent we become in the industry, because there are new challenges that we need to deal with, all right? And those new challenges are, well, how can we now deal is with sequence of values, all right? Especially huge amount of sequence of values. Wouldn't be better to have now a particularly approach to that, or use a design pattern, which is a way of how can we now solve a way how can we now, uh, given common problems, we find out common solutions. uh, and also is that in terms of doing that, all right, is that um, another things that we recurrently need is how we deal is with eventual values, all right. So because now our computers doesn't run or code statically here like embedded applications or applications that they don't need to talk about with other computers and so on and so forth. So now JavaScript and HTML CSS with the HTTP protocol enable us this communication across different computers. Okay, so how can now from the programming language respond, react on those eventual value, for single eventual value and for a collection of eventual value, a string of collection of eventual values, and also is that, well, how can we now is deal, or how can we now organize our code in a way that we can now, as I mentioned before, make it modular, or run this set of instructions when we need it, all right? And if we need to change the data, we would like to do that as well. This is now part of this anatomy of the function, which is scope. Well, scope is not exclusively to function, But historically, we use functions as a example by de facto, all right. But now we have also the block, all right, from ES5. But it turns out that from the function and the block or the scope in itself, which is a way of how now from the language perspective, relate is the a variable identifier with it is uh, 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 this is the way how it resolves variables identifiers. uh, yeah, it's a way how resolve is variables with it is identifier, right? And all of this happens before the code is executed. So another important features on the function is that how can we now is pass is data to that. How can we now runtime well modify is the data by using is the this keyword. So the this keyword is not whatever is on the left side, as a lot of people might tell you what it is a way of how now when we run that code, what it'll be is the execution context, or in other words, is the data that it has available at that moment when the code, when the function is run. So why is this? Okay, and we can now change that with the dot bind, with the dot call, with the dot apply, and each one of the functions well help us is to decide when this will happen. Okay, uh, so and another important feature is well how now can we is work with objects, which is another book here. How can we work with objects, and how can also is uh, yeah, how can we work with objects, and how can we now delegate property access to different objects that we link each other, all right, to save us implementation, or to delegate that property access to all of these other objects, right? So instead of inheriting that, which I do think that object-oriented delegation, which is a concept that I do think, which is the object-oriented or oriented delegation, delegation like this, which is the delegation pattern, all right? Because all of this is code reusability. The whole point of inheritance and delegation is that, hey, let me now is base that an object that describes the data and its functionality that somebody else has. They put effort, or not only one people, or a bunch of people actually put effort and time and dedication, sweat, blood, and a lot of uh, eyeshadow. I think eyeshadow is no, but I do want to mention is that is how do you say ojeras in English? Uh, uh, Dark circles, a lot of bag under the eyes, right? Dark circles, rings under the eye. Uh, well, as you can see, I am one of them. Well, we now, okay, get that, and so all of this, so we can get that implementations, and now junior developers or senior developers or any or somebody else that can understand how the things work, all right, makes sense. So let's get into this. Let's gonna use this implementations, right? But in terms of inherit all of its property, or the entire implementation, we just now have a reference to that. I definitely think that this prototype object change is a good way so far uh, to now uh, share data and its functionality. That is mind bending, man. Jesus. I don't know what these people were smoking. I don't know. I, I don't know what they were smoking, bro. But yes, delegation to me is a very powerful uh, thing. Absolutely, absolutely. So yeah, establish a delegation between two objects here. Absolutely, holy moly, bro! Instead of the classical object-oriented programming, and it turns out that in JavaScript, behind the scenes, this doesn't work like an extend. In fact, it works like a the prototype change. Again, object schizophrenia. Oh my god. And dual inheritance, delegation link. So in any case, that's quite beyond the scope of this. Was defined by Lieberman in 1986, a paper using prototypical objects to implement shared behaviors and using a prototypical objects to implement shared behaviors in object-oriented systems. It is used throughout macOS and its predecessor Next Step as a means of customizing the behavior of programmed components. Delegation can be characterized and distinguished from forwarding at slate binding of self. Uh, but again, I know this go beyond the scope of today's video, and I do just want us to jump straight forward to what we really care, which is now the not so um, mysterious life of variables. So, just to make this quick recap here on the scope and here. So right now I am on chapter 6, right? So in chapter 1 we look briefly at the importance of working with variables inside of a context, a scope, all right? And because we as an author, we can define as these variables inside of this scope function or block, and the way how they relate each other is analyzed by the scope rules, which happens before the code is executed. So, because in JavaScript we can define now values as functions and put now variables inside of that, the scope structure, which is determined before the code is executed, it won't be altered by runtime modifications, aka, so no matter wherever you execute that code, the scope structures remains. This is known as lexical scope. And we look at the classical theory, compiler theory, to just refresh a concept like what is a compiler and then its interpreter, specifically of the compiler, where you have now, hey, this is the this is the, how do you put it? Um, this is the phase in which now this source of text, the text that you put in your code right now to JavaScript, right? If this is a valid text, this is a valid text, it's going to be transformed into some instructions that the machine can understand. So this process, which in compiler it is made typically in three phases. So you have now the parsing and lexing, where now all of this token is transforming into meaningful language specific tokens, all right? And it's up to the tokenizer to decide if a particular token belongs to another one, or if this is a different token. All right, this is known as lexing. And then you have the uh, conversion of these strings of token into a structure that now we can identify, we as human and the computer can identify, all right? uh, and then usually it generate code, the code generation, the final phase. Okay, so um, because in JavaScript this is something, this the idea of defining, or the idea of describing is this, is because how now JavaScript evaluate errors, and that is, so syntax errors, early errors, and hosting, all of them are now evaluated before the code runs. How do you know that? Because when you now define is this particular stuff, it doesn't follow the same logic as a scripted language, right? As an interpreted language, one line of another. So it means that, well, the language behind the scene is doing something else, right? So indeed depend of the JavaScript engine, but most of them, what it's gonna do is to take now the source of text, is gonna convert into some intermediate representation of the code, which is a bytecode, and then further optimize the, or passing that optimization to the compiler, and then lastly is now generate is that code, right? So in our case, because now the scope is determined before the code is executed, and this is when we put these variables inside of this different scope and how they relate each other. A way to illustrate what's going on here, or according to Kyle Simpson, is to say, well, this is a this is when you as an author time define these variables, okay, define the variables and in which scope it's gonna live, and the range, right, the scope, it now this variable can widespread across your program. Well, it turns out that we have is marbles, buckets, and bubbles as a way to illustrate that. And when you define at author time, when you're writing the code, uh, where these variables we're gonna live and in which scope they're gonna belong to, well, it also is uh, a conversation that happening is with the scope manager, first with the compiler, and last but not and last first with the compiler and then with the engine. Okay, so the first step is, hey, the compiler talks when you're evaluating is your code, is analyzing your code, is analyzing the scope, all right, and this is like a conversation that I mentioned before that happens between the compiler and the scope manager, that actually is going to now ask the scope manager if this reference of this variable exists. All right. Again, this is just for illustrative purposes, and this is to describe is this is to describe is the association between the identifier in that particular scope. All right, and all of this happening is at execution time. But again, to at least understand this to at least to understand this at the beginning, and then it's up to you to decide if you want to dive deep into the uh, Alice or in the rabbit hole, all right? Um, well, good now. And the other is how now you, all right? How now you, uh, mm-hmm. The other is that how now you, uh, um, yeah, how now you, all right? Uh, Assign values to this identifier. And all of this happening is, well, at execution. So, this conversation is just a way to illustrate it. I don't want to actually is cloud the mind with things that might not be relevant. But I do find that at least to have now this initial um, um, how do you say that, the initial snack to let it on now digest a more heavy plate, all right, which is going into the spec and read about that. But its first song is this, okay? So, uh, and also that because this scope can now nest each other, and the way now how variables or how JavaScript knows at which statement uh, what variables it can have access, which is one, and the other is how now JavaScript deal with variables with the same name. It all turns out that uh, the first is because scope have a reference. Each one of those scope has a reference to the outer scope, all right, via the private variable. You can take a look at the spec called outer env, which is good. Uh, and the other is the way of how now JavaScript knows which variables or which value you are trying to access, or especially when variables with the same name at different nested scope. Uh, this it happens. This is known as shadowing, all right. And how this shadowing is now happen is lexically. So if you have now several names nested with the same name, all right, lexically you can have access to some intermediary variables. What you can do is to create a copy of that, but that is not lexical. That is copy, cloning. So uh, the other places where we so now take now looking at the different scope that we can have. So for example, like functions, and block, and how they behave, especially when we're using now variables, whether it's var, let, and cons. I also look at different scope, aka implied scope. So, for example, parameters. Uh, that's to me that for me that was mind blowing. Bro, it's like what can you do that? And this is a scope, and this is a valid scope. It's like holy hell. uh, All right. Um. Wait. What? Exactly. So we're looking at the function scope, the anonymous function, as well as the block scope, and also other or implied scopes. So for example, the parameters and the function named scope, right? The TLDR of this is that when you have now functions definitions and function expressions, uh, the name of those functions will be defined as the function definition by its identifier, and then the function expression is by the variable that is assigned to. And also this works for not also for function names but also for arrow function as well. So the point of this is, uh, when we look at uh, other scopes, we can use this, and the whole point of this scope, right, is that how can we now make uh, variables in our programs that can help functions, set of instructions, all right, to cooperate in this scope. That's the whole point of a scope. That's the whole point of a scope. Is that, and I know that this is something that might this is something that requires you to actually now get into this, do the work, write some programs, whatever it might be, okay, and well, get the feedback, not from me, not from me, from the actual code. And so it makes a lot of sense what this scope is all about. Scopes are, or scope act like a place where we can now define, where we can now ask a questions. How can we now make all of these variables that hold some values here and cooperate with each other's to do something? Okay, and that's okay. Interesting. So it makes a lot of sense, for example, in the case of the global scope, which is another one, and say, hey, this global scope, all right, this global scope, which is also at part of asking this question, is that how now JavaScript makes all of these different uh, programs, standalone programs, as it loads, to cooperate amongst them. All right, and at least in the browser, from browser wise, uh, you have now three ways to do that. So you have is the uh, ES6 models, all right. So by linking this one of, or by using as the import to fetch that file or ES models that contains more functionality and so on and so forth. This is one way to make that happen. The other is using the UMD, which is defining an enclosing scope, usually a functions, where you're going to define is your variables, that those variables have some instructions, aka some functions or models, all right, that now we can is ship that code to the browser and immediately running when we need it. All right. So this is another way of how can we encapsulate or how can and scope act as this playground where it need where different act as a playground for collaboration. Okay, where variables collaborate. And last but not least is the global scope. So by defining these global variables, you can now is access to the functionality, all right. And one of the most common functionality here, at least in in the global scope is like, for example, not only that JavaScript expose is primitive, so like undefined, null, infinite, nan, but also expose native, which is date, JSON, objects, strings, global functions, eval, parse int, namespace like math, atomic, and JSON, and friendly to JavaScript. All right, or friend of JavaScript, which is internationalization and WebAssembly, and also the environment hosting exposed to JavaScript. Some of this built-in. So, for example, is uh, uh, the web interfaces. So history, navigator, WebRTC, geolocations. So the web platforms API. The other is the timers. Uh, no, but this is more related to the language. Uh, mm, okay. So console is another word. The DOM as well. So where exactly is this global scope? So depend on the JavaScript environment that you are executing, that you're working. Different JavaScript environments handle the scope of your program, especially the global scope, differently. So it is quite common for JavaScript developers to harbor misconception without even realize it. So browser window is how you can access to that, right? So you can define its variables like this, all right, and also is using the window object, so you can bypassing that. Uh, Another thing is that global shadowing globals, which unfortunately you can't do this kind of stuff, all right. And the other is that you can't have access to the DOM globals. That's to me is pretty mind-bending, fucked up stuff, bro. That you can have access via the window object is the idea of that element. Mm-hmm. And what is the window name? Mm-hmm. With name, you can also do this as well. So the other is the web workers. So web workers is another environment that allows to run JavaScript in a completely separate thread that doesn't have access to the DOM, and it is exposed certain web APIs. So for example, like Navigator. So here, the name of this global is called self. It makes a lot of sense. It makes a lot of sense. The other environment that you can run is a RELP or the developer tools. All right. So the thing here is that with respect to our discussion here about scope, such observable difference in behavior may include the behavior of the global scope, hosting, and block scoping declarators, as well as let and count and see chapter C when used in outermost scope. All the takeaway is that developer tools will optimize to be convenient and useful for a variety of developer activity are not suitable for environments to determine or verify explicitly any nuance here. So these developer tools or RELP, the global scope doesn't always behave the same as the browser or the web workers or the ES6 models, which is another this is not an environment, but this is a way of how you can organize your code. And this code organization, you don't have access to okay, in this scope organization you don't have access to the let me see if this is ES6 introduced first-class support for model pattern, covering Chapter 8. One of the most obvious impact of using ESM is how it changes the behavior of the observably top-level scope in a file. Recall this code snippet from early, which will adjust to ESM format by using the export keyword. If that code is in a file that's loaded as an ES model, okay. If that code is in a file that's loaded as an ES model, it will still run exactly the same. Yeah, if that code is in a file that's loaded as an ES model, it will still run exactly the same. However, the observable effect from the overall application perspective will be different. Despite being declared as at the top level of the model file in the outermost obvious scope, student name and hellos are not global variables. Instead, they are model wide, or if you prefer, model global. However, if a model there is not implicit model wide scope object. For this, in a model there is not implicit model wide exactly. So model doesn't have any model wide scope object. For these top level declarations to be added as property, as they are in when declaration appeared in the top level of non-model JS file. This is not to say that global variables cannot exist or be accessed in such programs. It means that variables, it's just that global variables don't get created by declaring variables in this top level scope of a model. You can have access to, but you can define them in a global scope. The model top level scope is descended from the global scope, almost as if the entire content of the model were wrapped in a function. Thus, all variables that exist in the global scope, whenever they are on the global object or not, are available as lexically identifiers from inside the model scope. ESM encourage a minimization of reliance on the global scope, where you import whatever models you may need for the current model to operate. As such, you less often see usage for the global scope or its global object. However, as noted earlier, there is still plenty of JavaScript and web globals that you will continue to access from the global scope. There is still plenty of JavaScript and web globals that you will continue to access from global scope, whether you realize or not. And the other is Node. One aspect of Node that often catch JavaScript developer off guard is that Node treats every single JavaScript file that loads, including the main one you start the Node process with as ES with a model. Exactly. ES model or common JS model. See in chapter 8. The practical effect is that the top level of your Node programs is never actually the global scope. The way, because now this environment processes this differently. Each one of those standalone files, including the main one, is a model in itself. A common JS or an ES6 model. Makes sense. So the way it is when loading a non-model file in the browser. At some time of this writing, Node has recently added support for ES model. But additionally, Node has from its beginning supported a At this time of his writing, Node has recently added support for ES model. But additionally, Node has from its beginning supported a model format referred as common JS, which is the way how you can have access to this is via the model global variable. I'll be right back. All right, and we're back after that huge overview, right? And of course, a couple hours later, because now the settings has changed. Finally, we're gonna take a look at the well, the not so secret life cycle of variables. Let's get into this. I'll be right back. All right. So, chapter 5, the not so secret life cycle of variables. By now, you should have a decent grasp of nesting of a scope from the global scope downwards, called a program scope change. Yes. But just knowing which scope a variable becomes sorry. But just knowing which scope a variable comes from is comes come from is only part of the story. If a variable declaration, okay, so if a variable declaration appear past the first statement of an scope, okay, if a variable declaration appear past the first statement of an scope, how will any reference, if a variable declaration appear past, interesting how they mentioned this. If a variable declaration appear past the first statement, okay. If a variable declaration appear past the first statement of a scope, that sentence here, translate. That's interesting. If a variable declaration appear past, exactly past, because this means like beyond that. If a variable declaration appear past the first scope of a statement, hey, the first scope of a statement. But this is interesting because even in English, it's describing things like backwards from POP, from Spanish POV. Okay, so if a variable declaration appear past the first statement, appear past. That's interesting. This combination appear past. If a variable declaration appear past the first statement, okay, si una declaración de variables aparece más allá de la primera declaración, if a variable declaration appear past the first statement of a scope, so declaration and statement here. Okay, if a variable declaration appear past the first statement of a scope, so if a variable declaration appear past the first statement of a scope, how will any reference to that identifier before the declaration behave? Exactly. How will any reference to that identifier, the name, before the declaration, exactly, how will any reference to that identifier before the declaration behave? What happens if you try what happens if you try to declare the same variable twice in a scope? Oh, in a scope. But this is to answer the two questions here. These two questions. So by just knowing which scope a variable, by just knowing which scope a variable comes from, is only part of the story. Hey, okay. So which variable scope? So by just knowing which scope a variable comes from, okay, is only part of the story. So if a variable declaration appear past the first statement of a scope, how will any reference to that identifier before the declaration behave? How will any reference to that identifier before the declaration behave? And what happens if you try to declare the same variable twice in a scope? JavaScript particularly flavor of lexical scope is rich with nuance in how and when variables come into existence and becomes available to the program. When can I use a variable? But this is the two questions here that we want to answer here. This is the two questions we do want to answer. Okay, first is so just knowing which scope a variable come from. Okay, but just knowing which scope a variable come from is just part of the story, because if a variable declaration so by just knowing which scope, by just knowing only just knowing which variable scope, just knowing which scope a variable comes from is just part of the story. Because now what happened if a variable declaration, okay, so what happened if a variable declaration appear past, okay, what happened if a variable declaration appear past the first statement of a scope? So if this variable declaration appear past the first statement of an scope, exactly, past of an scope. Okay. So what happens if a variable declarations appear past first, the first appear past the first statements of a scope? How will reference? Okay, because I want to illustrate this. So just by knowing which scope of variable come, by just knowing which scope variable, oh my god. So by just knowing which scope a variable come from is just part of the story, as I mentioned. So if a variable is statement, if a variable statement appear past the first statement, if a variable declaration appear past the first statement of a scope, how will any reference of that identifier before the declaration behave? And the other is, what happens if you have now if you declare the same name, the same variable name twice in a scope? But these two particularly question, which is part of the hoisting, these behaviors. Okay, so when can I use a variable? At what point those variables becomes available to use within its scope? Another valid question. There might seem to be an obvious answer, but after the variable has been declared or created, right? But not quite right. So consider this particular example. So this code works fine. You may have seen or even written code like it before, but did you ever wonder how it or why it works? Specifically, why you can access the identifier greeting from line 1 to retrieve and execute a function reference. Or even though the greeting function declaration doesn't occur until line 4, which is describing it is this. If a variable declaration, whether it's like a function or a var or any of the syntax form, a variable, let, and cons, if a variable declaration appear pass, okay, if a variable declaration appear pass, all right, if a variable declaration appear past the first statement, past the first statement in an scope, how will any reference to that identifier will behave or behave? So recall chapter 1 points out that all identifiers are registered to their respective scope during compile time. Moreover, exactly, all identifiers are registered to their respective scope during compile time, during parsing time. Moreover, every identifier is created at the beginning of the scope it belongs to. Every identifier is created at the beginning of the scope it belongs to. But again, the identifiers respected exactly. So all of the identifiers are created at compile time. Okay, and these identifiers are creating at the beginning of the scope. It belongs to every time that scope is entered. So the term most commonly used for a variable being visible from the beginning of its enclosing scope, even though its declaration may appear further down it is in the scope, is called hoisting. So the variable's visibility in an enclosing scope, okay, the variable visibility, a variable used for a variable being visible from the beginning of its enclosing scope. So a variable that is a variable that is initialized, or a variable that is visible, because that's the word it's using. A variable that is visible from the beginning of its enclosing scope, even though it is declared, exactly, visibility and declaration. Okay, so a variable that is being visible at the beginning of the scope, of the enclosing scope, even though the declaration may appear further down the scope, it is called hoisting. But it's talking about the visibility here, because at the end of the day, it's in this. So the visibility of an identifier, a variable being visible, is a variable that is visible from the beginning of its enclosing scope. In this case, let's assuming that this is global scope. So a variable that is visible in its enclosing scope, even even though that function even though that declaration may appear further down the scope, it is called hoisting. But hoisting alone doesn't fully answer the question. We can see an identifier called greeting from the beginning, all right, of the scope, but why can we call the greeting function before it is declared? In other words, how does a variable's greeting have any value, the function reference, assigned to it from the moment that scope start running? So how this value here, how does the variable greeting thus contains now a value of the function scope, or the function reference, assigned to from the moment the scope start running? And the answer is a special characteristic of a formal functions declaration. This is when we're starting to need to look uh, at this, at the ECMAScript. There you got it. Hostable declaration. But it's talking about is the this is hostable declaration. It's starting to make a lot of sense. Declaration and a statement. Mm-hmm. Mm-hmm. Hostable declarations. Let me see if they mention something here. Hoistable declaration. Is this? Okay. Hoistable declaration. Hoistable declaration. It can be either a function generator, async function, and async generator here. So functions declaration is this. And here's the finding is the early errors and function body contain uses strict. So hey, if this contain now, for example, is the same name, you're gonna throw an error, for example, or if the name is a val or argument, without the strict mode, it's gonna throw an in the strict mode, it's gonna throw an error. Mm-hmm. Bound names contains formal parameter function body, formal parameters and function body, and there you go. The lexically declared names of a function body does not include identifier bound using var or function declaration. And the function body contains use strict. But again, all of this is because we are reading is the spec here. Functions declaration instantiation. And this functions declaration instantiation, when you now pass this, all right, and you actually call that, where are you? Function body, runtime semantics. Yeah, but what the? Okay, there you got it. Runtime semantics evaluate function body. This syntax directed operation. Anytime that you read this stuff, is that is an algorithm. Is an algorithm of which is associated with more products. Okay, it is an algorithm that produce. It is an algorithm that produce is okay, our algorithm associating of the production, a production that has multiple alternative definition will typically have distinct algorithm for each alternative. So in other words, the syntax directed operations are our algorithm that evaluate. Okay, this algorithm that evaluate is giving a specific syntax. Okay, this syntax operations, syntax directed operation. Oh, makes a lot of sense. Even in the name, it is this. Okay. Mm-hmm. Mm-hmm. Algorithm that algorithm triggered. Okay, it is safe to say that syntax directed operations are algorithm triggered by it is a by ECMA script syntax specific. Mm-hmm. Exactly. Exactly. It's like anytime it read this specific syntax, Now it's gonna run an algorithm, a series of step behind. Okay, so for, so yes, they're essentially algorithms whose invocation is determined by the specific syntax structure. Holy fuck. Okay, okay, okay. This syntax directed operation is when the language read this particularly token, whether it's a function or in our case a function, uh, with this as the evaluation of a function body, okay, takes the argument function object an ECMAScript function an argument list, a list of ECMAScript language value, and return a completion or throw completion, and it is defined piecewise over the following production. It say, hey, I'm going to perform now the function declaration instantiation, then perform the evaluation of its function statement list, and all of this, right? Evaluate function body, function declaration instantiation. And here, this is an abstract operation, which is an algorithm that happened without your consent, that describes this. Functions declaration instantiation takes arguments fun, an ECMAScript function objects, an argument list, a list of ECMAScript value, and return either a normal completion, unused, or throw completion. Function is the function object for which the execution context is being established. So it performed the following step when called. It say let callee be the running execution context. So it's creating a running execution context, and then all of this here on functions definition, what the thing is doing. Evaluate function body. So it assign the running execution context, the code be the ECMAScript code, the strict and the formal parameters from this function that is receiving. Parameter names be the bound name of formals. If parameter name has any duplicate entry, let has duplicate be true, otherwise has duplicate be false. Okay, let simple parameter list of formals has parameter expression. Holy moly, you can have now parameter expression. You can evaluate in the parameter things here contain expression. Okay, parameter expression and all of this. uh, Let var names be var declare of code, var declaration, var scope declaration, lexical name be the lexical declare name of code, and function names be the new empty list. And let functions to initialize by be a new empty list. For each element of var declaration in reverse list order do is neither a variable declaration nor a for binding nor a binding identifier, then is either function declaration generator async or async generator. Let the function the sole elements of bound names, and if function's name does not contain function, then insert function as the first element of the function name. Now, if there are multiple declarations for the same name, the last declaration is used, and insert D as the first element of the functions to initialize. Let the argument object needed to be true. If function this mode is lexical, then arrow functions never have an argument object. And here is describing is this keyword with arrow function is lexical, then note arrow function never have arguments object, and set the arguments object needed to false. Else if parameter names contains arguments, then set the arguments object needed to false. Else if has parameter expression is false, then the function name contain arguments of lexical name contain arguments, then set arguments object needed to false. So in other words, you can have access to the arguments because the algorithm doesn't expose that to you. If string is true, has parameter expression is false, the only single environment record is needed for the parameter, since call to eval in strict mode cannot create new bindings which are visible outside of the eval. Let env be the lexical environment of callee context. And note, a separate environment record is needed to ensure that binding created by direct eval calls in the former parameter list are outside of the environment where the parameters are declared. Let call env be the lexical environment, new declarative environment. Assert that the variable environment of callee and callee context and callee environment are the same as the environment record. Mm-hmm. Okay. Callee, a lexical environment, and callee context is the lexical environment. Okay. For each string of the parameter, if argument, let parameter as binding, the iterator record. So here is describing is this series of steps, one by one. Holy moly. Alright. Okay. Mm-hmm. Holy moly. Insert the lexical environment, lexical scope declarations, and is here. But this is actually describing is all those series of steps that's happen behind the scenes. Okay. Makes but again, because this particular layer of abstractions that as software engineer we are exposed to, uh, the only thing that we really care about this is that how the things behave. I don't care how it does, I care what it does. Mm, mm, mm. Okay, especially if you're gonna build products and projects and stuff like that. Okay. The term most commonly used for a variable. Okay. Okay. Mm-hmm. So, in other words, how does the variable greeting have a value, have any value, the function reference assigned to it from the moment the scope starts running? So the answer is a special characteristic of the formal function declaration called function hoisting. So when a function declaration name identifier is registered at the top of its scope, it is additionally auto-initialized to that function reference. That's why the function can be called throughout the entire scope. One key detail is that both function hoisting and var flavored variable hoisting attach their name identifier to the nearest enclosing function scope, or if none, the global scope, not the block scope. Exactly. This is the feature here, at least for functions. In var declare, in var declarations. So it is identifiers will be attached. It is identifier will be attached to the nearest enclosing function scope, not the block scope. So the declaration with let and const still hoist in CTDC discussion later in this chapter, but these two declaration forms attach to their enclosing block rather than just an enclosing function, as with var and function declaration. See scoping with blocks in chapter 6, in the next chapter. But again, all of this is just to look at this, dive deep into this, and truly understand where this comes from, which is from this syntax directed operation. It's just a fancy way to say, hey, when I read this, when the JavaScript engine read this syntax, well, I'm going to do this. That's all. So, for example, when I read is that identifier is now have a parenthesis, I'm going to evaluate that. Mhm. Especially for functions declaration. Hoisting declaration versus expression. Function hoisting only appears to formal functions declaration, specifically those which appear outside of blocks. See in FBI in chapter B. Not the function expression assignment. Consider is this. Line 1 greeting here is gonna throw a type error, not a reference error here. Interesting. If you say, hey, uh, greeting, and then I define as this greeting with a functions declaration called greeting, function name expression called greeting, say, hey, console log here, hey, right? It's gonna throw now a type error, not a reference error, because variables and functions, in this case variables, are hosting, aka we can it is available to us uh, it is available to us, it is visible to us at the beginning of its enclosing scope, even after we define we we declare that later on. But though that work is for functions declaration or variables declarations, not for function expression. Because what happened here is say, hey, type error greeting is not a function. In other words, uh, the value that I have here is not a function. That's interesting. So this identifier that you're trying to call is not a function. Perhaps you are looking this as a, perhaps you define this as a variable expression, so on and so forth. Okay. Or exactly, perhaps, so that identifier again is not a function, and it's telling you that. But the kind of error throw is very important to notice. A type error means we're trying to do something with a value that is not allowed, right? So if for some reason we do want to evaluate is what is the value of greeting at that moment, it say, hey, this is undefined initially, exactly, until the assignment happens. Exactly. Notice that the error is not a reference error. JavaScript isn't telling us that it couldn't find the greeting as an identifier in the scope. It's telling us that the greeting was found but doesn't hold a function's reference at that moment. Only functions can be invoked, so attempting to invoke some non-function's value result in an error. But what does greeting hold if it's not a function's reference? Well, in addition to hostings, these variable declarations are automatically initialized to undefined. At the beginning of their scope again, the nearest enclosing function or the global. Once initialized, they are available to be used, assigned to, retrieved to, so on and so forth, throughout the whole scope. So on that first line, greeting exists, but it holds only the default value, as we can see here. It only holds the default value. It is not until line 4 that greetings gets assigned the function reference. Pay close attention to the distinction here. A function declaration is hosted and initialized to its function values. A function declaration is hosted and initialized to its function values. So for example here, to its functions value. A variable hosting, a variable is also hosted and then auto initialized to undefined, and any subsequent function expression assignment to the variable don't happen until that assignment is processed during runtime. This is the reason why we're looking at how JavaScript behave like a compiler when it analyzes code. Specific syntax operations like greetings and vars, functions and vars. In both cases, the name of an identifier is hosted, but the function reference association is handled at initialization time, beginning of the scope, unless the identifier was created in a formal functions declaration. Exactly. In both cases, the name of an identifier is hosted, but the function's reference associated isn't handled at initialization time, beginning of the scope, unless the identifier was created in a formal functions declaration. Mm-hmm. Exactly. In both cases, uh, the identifier is hosted, but the function's reference association isn't handled at initialization time, unless the identifier was created in a formal functions declaration. So variable hosting, and let's look another example of variable hosting. So for example, like this, you have now the value here assigned, but not the latest one. Through a greeting is in declared until line 5, it is available to be assigned to as early as line Y. Oh, okay. Yeah, like this. But I haven't declared that. Through greeting isn't declared until line 5. It is available to be assigned to as early as line 1. There are two necessary parts of this explanation. The identifier is hosted and it is automatically initialized to the value undefined from the top of the because here you say, hey, this is now the initialize the identifier. Mm-hmm. Using variable hosting of this sort probably feels unnatural, and many readers might rightly want to avoid relying on their programs. But should all hosting, including function hosting, be avoided? We'll explore this different perspective on hosting in more detail in Appendix A. In Appendix A. Appendix A. Exploring further, but with what? No function names, diggy, missing names. Names are descriptors, arrow functions, immediately involve function expression variations. There you got hosting. Chapter 5 articulated both function hosting and variable hosting. Since hosting is often cited as a mistake in the design of JavaScript, I wanted to briefly explain why both of these forms of hosting can be beneficial and should still be considered. Give hosting a deeper level of consideration by consider the method of executable code first and function declaration last, and semantic placement of variables declarations. Okay, okay, functions hosting. Exactly. So in terms of readability, okay, or the case I'm presenting here as a devil advocate, right, is to is for function execution, yeah, executable code first and declaration last, and semantic place of variables declaration. Why is this? Because most of the time, if you have this hoisting, you're going to now read your code first, that is going to be executed, and then the declaration. So now it feels much more natural way to organize stuff in this script, in this text. For example, like this, and then you return whatever, and then the function here. So when I first open a file like that, the very first line is executable code that kicks off its behaviors. That's very easy to spot on. Then if I ever need to find and inspect get student, I like that in the first line of executable code. But again, this is when you, for example, in Node. For example, in Node, so you have dependency, the public API, and private implementations, right? Notice how the catching of the variables are in private sections of the model layer. That's because I don't plan to expose them publicly. So I organize the model so they are located alongside the other hidden implementation detail of the model. But I had a few rare cases where I need the assignment of those values to happen above before I declare the exported public API of the model. So for instance, you get is this. We are assigning and binding now is catch here. Okay. So you have now a public API, it's student at student, and then refresh the data. But you're gonna say, hey, I do want is this. I do want is to now that function bind this catch or pass these arguments here. Mm-hmm. Bind this catch. So anytime that you call this, you have these arguments. Okay, and here what you're saying is well, uh, assign assign the target to this object. Object dot assign. Object dot assign. Okay, it's like assign the properties here. Assign the properties because this is the target and the source. Assign the property. Assign the property here from the source to this. So assign the properties to a target or copy all of the property from one of the objects from the source to okay. So copy all of the okay. So copy all of the property of this object. Copy all of the property of the source into the target. So in other words, what it's going to do is going to rewrite this. Okay, rewrite this and here as well. It's copying. It's copying. Okay. It's a stepping over. Okay. Okay. So you're saying is that now stepping over these variables into this object. So stepping over this the property of this object or copy the property of this object and step over those that have the same name in this target objects. Okay, as a way to enhance its functionality, right? Because at the end of the day, that's what you want to do, is to enhance the functionality here. Hey, this is now the shape of this particular object. And I need a catch variable to have already been assigned a value. Because that value is used in the initialization of the public API, the .bind partial application. Should I just move the var catch up to the top above this public API initialization? I need a catch variable to have already been assigned a value. Because that value is used in the initialization of the public API, the bind the partial application. Should I just move the var catch up to the top about this public initialization? Well, perhaps, but now it is less obvious that the var catch is a private implementation detail. And here is the compromise. I have somewhat rarely used this. See the variable hoisting? And here I define is the identifier here and then assign a value here, which is now empty, and then the private implementation of this catch. I have declared the catch down there it belongs logically, but in this rare case, I have used it early up above in the areas where its initialization is needed. I even left a hint at the value that they assign to catch in code in comment code. Use here but declare below. That's literally the only case I have ever found for leveraging variables hosting, and the case of var. Speaking of variable hosting, let's have some real talk for a bit about var, a favorite villain dev love to blame for many of the woes of JavaScript development. In chapter 5 we explore let and count and promise. We have revisited where var failed in the whole mix. As a layout the case, don't miss, var was never broken. Let is your friend, count has limited utility, and the best of both worlds is var and let. Those throw out of the war. var is fine and works just fine, and it's been had for around 25 years and will be around and useful and functional for another 25 years or more. Claims that var is broken, deprecating, outdated, dangerous, or ill-designed, deprecated, dangerous, broken, are bogus bandwagoning. Does they mean var is the right declarator for every single declaration in your program? Certainly not, but it still is a place you in your programs. Refusing to use it because someone on your team choose an aggressive linter opinion that chokes on var is cutting off your nose to spit your face. Okay, now that I got you really riled up, let me try to explain my position. For the record, I'm a fan of let for block scoping declarations. I really dislike the temporal dead zone, and I think that was a mistake. But let itself is great, and I used often. In fact, probably I use it much more or more than I use var. Constantly confused. The thing with cons is that it is mutation, not it is assignment, not the mutation, and we might unfortunately think that it is based on it will. Mm-hmm. Hey, this but it's talking about the identifier. Hey, this identifier, just to play devil advocate here, because at the end of the day, these identifiers, uh, these syntax forms of identifiers are describing is how it behave in terms of its assignment. Okay, hey, you can reassign or redeclare this identifier again. Okay, but it's talking about from the identifier definition, not its value. And unfortunately, unlike any other programming language where they have to change that for to say, hey, final keyword, okay, in Java, okay, where it say, hey, this keyword is prevented from being overridden or modified. Hey, this is the final value. And this is where the confusion kicks in, bro. Okay, this is the final value here. Because you can also have in Java is now cons, for example. Okay, diggy cons. There's no cons here. That's interesting. Oh, look at this. There is no const. Okay, there is no const. Okay. So the language here now say, hey, you want no? No. No. Okay, there is no. Okay, it is only final. Okay. Okay. var and let in my mind counts is very rarely useful. So this is only two horse races between let and vars. Horse races. But it's not really a race either, because there doesn't have to be just one winner. They can both win different race. The fact is you should be using both var and let in your programs. They're not interchangeable and you shouldn't use var where a let is called for. But you also shouldn't use let where a var is most appropriate. So where should we still use var? Under the circumstance Under what circumstance is a better choice than let? For any time you need that identifier be scope in a function, well, but if you want to make that happen, or if you need that identifier scope in that block, you define there as it is. You using let. So you can use let in this top level scope, but it's not the best tool for that job. I also find that if you use let everywhere, then it is less obvious which declarations are designed to be localized and which ones are intended to be used through the function. By contrast, I rarely use var inside a block. That's why let is for. It is best use the best tool for the job. If you see let, it tells you that you are dealing with a localized declaration. If you see var, it tells you that you're dealing with a function wide declaration. Simple as that. In the case of this or here, there you and the student record variable is intended for use across the whole functions. Var is the best declarator for to tell the reader that by contrast record. Okay, this is explaining is this. In addition to this best tool semantic argument, var has a few other characteristics that, in certain limited circumstances, make it more powerful. One example is where a loop is exclusively using a variable, but is conditionally clause, cannot see block scope declaration inside the iteration. So here you say this. I do want is to now hoist this per function and here per block. So I want to call this, get a new value from the function call, and then do some sort of assertion here. The result code is this. Alright, var is done. It means that now when it's going to evaluate this has changed and therefore is now get out of here. Here the result is clearly only inside of this block. Another helpful characteristic of var is seen with the declaration inside unintended block. Unintended blocks are blocks that are created because the syntax requires a block, but where the intent of the developer is not really to create a localized scope. The best illustration for unintended scope is a try-catch statement, not really a block scope. There are other ways to structure this scope, yes, but I think this is the best way giving various trade-off. I don't wanna I don't want to declare records with var and let outside of a try block and then assign to this in one of both blocks. I prefer initial declaration to always be as close as possible, ideally the same line, to the first usage of the variable. In this simple example, that will only be a couple of lines in distance, but in real code it can grow. Mhm. Okay. Okay. Hmm. 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 So there are other ways to structure this code, but yes, I think this is the best way given various trade-off. I don't want to declare records with var or less outside of the try block, and then assign to it one or both block. I prefer initial declaration to always be as close as possible. I prefer initial declaration to always be as close as possible to the first usage of the variable. In this simple example, that will only be a couple of line distance, but in real code, it can grow to many more lines. The bigger the gap, the harder it is to figuring out what variable from what scope you are assigning to. var used at the actual assignment makes it is less ambiguous. Also notice I use var in both the try and catch block. Exactly. But you wrap this scope into a you wrap this in a function scope. That's because I want this to signal to the reader no matter which path is taken, record always get declared. Technically, that works because var is hosted once the function scope, but it's still a nice semantic signal, not really a block scope here. Mhm. But it's still a nice semantic signal to remind the reader what either var ensure if var were only using one of the blocks and you were only reading the other block. If a var were only using one of the block. Mm-hmm. Mm-hmm. Okay, so you are now hosting this. In other words, is you're making the identifier visible. You're making the identifier visible at the top of this function scope, where the value it is initialized as undefined, and later on, no matter which path it take, you then assign the value to. Mm-hmm. Mm-hmm. But it's still a nice semantic signal to remind the reader what either var ensures. If var were only using one of the block and you were only reading the other block, you wouldn't as easily discover what record was coming from. This is, in my opinion, a little superpower of var. Not only it can escape the unintentional try and catch block, but is allowed to appear multiple times in a function scope. You can do that with let. It is not bad, it is actually a little helpful feature. Think of var more like a declarative annotation that remind you each uses where the variable comes from. Aha, right. It belongs to the whole function. Exactly. Exactly. So anytime that you see these var declarations, no, it belongs to the function scope. This repeated annotation superpower is useful in other cases. So for example here, do something with data. Purely an annotation to remind us. And use data again. Purely an annotation to remind us. The second var data is not redeclaring data, is just annotating for the reader benefit that the data is a function wide declaration. That way the reader doesn't need to scroll up 50 lines of code to find out the initial declaration. I am perfectly fine with the reusing variable for multiple purpose through a function scope. I am also perfectly fine with having two uses of a variable be separated by quite few lines of code, and in both cases the ability to safely redeclare annotate with var helps make sure it can tell where my data is coming from, no matter where I am in the function. Again, sadly, let cannot do this because you can redeclare this. And there are other nuances in the scenario where var turns out to offer more, to offer some assistance, but I'm not going to belabor that point any further. The takeaway is that var can be useful in programs alongside with let, and the occasional cons are willing to creatively use the tool the JavaScript function provide to tell a richer story to your reader. A richer story to your reader. Are you willing to creatively use a tool of your language provide to tell a richer story to your readers? Don't just throw away useful tools like var because someone shamed you into thinking it wasn't cool anymore. Don't avoid var because you get confused all once years ago. Learn these tools and use them each for what they are best at. So what's the deal with TDC? We explain was explained was explained to this. All right. So that'll be all for this video. Take care.